Hello and welcome to Python Objects. I'm Chuck Severance, and we're well on our way to getting through all this material in the Python. So this lecture is in a weird place. I even debated where to put it in the book. I don't really want to teach you how to write a lot of object-oriented programming, but we're going to start using objects, and I want to be able to use the terminology. And so as much as anything, this lecture is about terminology and understanding the words, things like methods and method signatures and variables and inheritance. And so think of this as a terminology lecture rather than a learn how to program or learn how to use this. It's not something you're going to figure out right away. And there'll come a time when you as a programmer really want to start using object-oriented programming. It's really a powerful and wonderful technique, but I think it's too early as a beginning programmer to really say, oh, let's write a bunch of objects. So just relax and enjoy and learn this material and think of it as sort of a theoretical thing rather than, a how to program thing. And so part of this is we're going to start reading data structures, and data on how to use all these libraries, etc. And we're going to see the word objects, right? And then we're going to start hearing them. And I want you to be able to read the Python documentation so that you understand what's going on. And so, the word objects should make sense to you, even though you're not going to write a lot of object-oriented programming. And so page upon page upon page, database stuff, which we're going to talk about soon, is uses objects all over the place. And the beautiful soup uses objects. We've kind of been using them, and I've been waving my hands, and I use the word method without defining it. But now it's really time to define it and go to it. So I want to review from the very beginning what we think of as a program. So the classic program, my favorite little minimum program, is our little elevator floor converter, which converts from European elevator floors to United States elevator floors. And the key to this is that it's input, processing, and output. And this is a good way to model any program. And in that process, we've got variables, and we've got logic, we've got algorithms, we've got loops that we write, we've got all kinds of things. And we construct a series of steps to achieve some goal. In object-oriented, and frankly, you've been using object-oriented all along, the program has lots of objects, and we're sort of putting stuff into these objects, taking stuff out of one object and putting it into another object. And you've actually been doing this all along. As soon as you're looking at dictionaries and lists, you're doing objects. And so an object is quite a little thing. It's sort of its own little space inside of a program that contains code and data. And so we're working together. All these objects are now working together. It's a bit of self-contained code and data. And it is one way to take a very complex problem and make it easier by breaking it into separate things that can be engineered and developed separately. So you've been using string objects, or maybe you'd use beautiful soup or something. These are powerful capabilities, and if you had to look at all of them, it's just, hey, here's a thing, use this object, it'll do these things for you, and there's lots of details inside of it. Just don't look at it. Don't worry about it. And so there's boundaries, that things that you can use, things that you can look at, and things that really you don't bother looking at. You go read the documentation and use it, and away it goes. But then someone had to write that, and so they built an object. So what we're going to do is look a little bit under the covers of what it takes to build some of these objects. And so if we think of this program that originally just sort of did processing, we can think of it as having some kind of an input, right, coming into our program. And we have a string object, a dictionary object, maybe eventually some objects like a database object or an object that we eventually define. And you can think of as we're receiving data, it comes in an object, which is a string object, where we start putting the strings in dictionaries and do whatever. We pull out a list of them. And so you can think of data as moving between these objects. And like I say, even strings, in the first week, first lecture, first week, first everything, we were using objects, and we've been using them all along. And so you can think of every string and every dictionary as a little program all by itself that has a bit of code and a bit of data. And so a string has the data, which includes all the characters that make up the string, but then there is a method called upper that does uppercase, or rstrip that strips off the right, a white space from the right. And so it's like they're almost little programs that have inputs and outputs themselves, and we can make lots of them. And there's lots of cooperating objects that make up an application. And one of the nice things about the object-oriented pattern is that they form boundaries, and within the boundary, if you're inside the object, you can say, look, I'm going to build you a string object or a database object or a beautiful soup object, and I'm going to build this capability and I'm going to give it to you in the form of an interface, and I'm not really going to care how you use it. And so we have this sort of visibility wall where I'm going to make an object and I'm going to let you use it, and the maker of the object doesn't necessarily have to know every single thing about the use of that object. But so just like inside the object, they don't have to worry about what you're doing with the object outside of it. When you're outside the object, you don't have to worry about what's going on inside of it. We, as the user of the object, we talk to its interface and we get things from it and give things to it and use functionality within that object, but we don't have to look inside of this. We can just say, oh, it's a nice little magical thing. We read the documentation, we read a web page, and it told us to do this, this, and this, and away you go. And so it is sort of this isolation boundary that works both for the programmer who's writing the object and the programmer who's using the object. And so it's a very nice pattern, and so you'll see how we're going to build code and we're going to group it together, and then we're going to be using it sort of as a big blob of stuff. So some definitions in this space, words that I want you to understand. When we're going to create one of these things, one of these objects, instances, that has some data in it and some code in it, we have to be able to define the shape of this object. What code will each object have in it, and what data will each object have in it? And that's called a class. The key to a class, and this little picture that I've got up here in all these slides, is a key. The class is a template. It's not the thing itself. So it's a cookie cutter. It knows a lot about how cookies are made. And if you have cookie dough and you hit the thing, then you make as many cookies as you want. And so this nice little cookie picture is a great, mental model of how it works. The class is the template, and then the object are all of the cookies that are made from that template. But the template defines the shape and the nature of the class. So the code that we write is going of each of the objects. The code we write is the class code, and then later we say, oh, let's take that template and make ourselves an object or an instance. Now, as we're defining a class, we have two basic things that we put in the class, and there's a couple of different terminologies for this. One is method, which is code. It's like a function that lives inside of a class. Not a function that lives inside your program, but one that lives inside of a class. And so this is a scoping thing. A method is really just a function, but it lives inside the class. And then fields or attributes are data items that are in the class. And so they're variables that are defined in the class. You can define variables outside the class that you use in your program, and you've been doing that all along. But if you're saying, I'm going to build this capability, and it's going to have data inside of it and code inside of it, the code is the method or message, and field or attribute. And there are just two different sets of terminology. Method is what I'll probably use. If you look in some object-oriented patterns like Smalltalk or Apple, they often will call these messages. So you can either access a method inside of a class or an object, or you can send a message to the object. The same is true for field and attribute. It's just a chunk of data that's in the object that you may or may not have the right to access. So, like I said, a class is a template. It defines the characteristics of the objects that we're going to use to make it. It is the cookie cutter. So, dog is sort of the exemplar. Lassie is a particular dog, and so dog has fur, and dog barks, and dogs do all these things, and so we know something about dogs, but it doesn't mean we have a dog, right? The class is a more abstract concept that when it's time to get a dog, we know certain things about dogs. Instances, or objects, are once we say, oh, time to make a cookie from the template, time to get a dog, we know something about dogs. That's the creation of an object, and that we call them instances, instance of a class. So the class is it doesn't exist, but we say make me a new object using this class as its template. Oh, and now make me another one. And so we can have many, many objects from one class. So just like many cookies from one cookie cutter. Method is a bit of code that lives inside of an object. It's like a function, but it's scoped to within the object or within the class. Okay, so that kind of gets us started on some of the terminology, and we'll come back and we'll take a look at how we write code that's object-oriented. Okay, so now that we've gotten through the definitions, let's work into some sample code. But hey, look at this. We've got ourselves a cookie cutter and some cookies. So remember that a class is a template. It's not the actual thing. An object is an instance of a class. So you have to take the class and do something to make the object. And actually you can see here's some other classes. There's clearly a sort of a snowflake class and a gingerbread man class. That's an object, object, object. Somewhere out here there is a snowflake class and a gingerbread class, but we got a snowman object and a snowman object and a snowman class. So class is the template, object is the instance. So here's a bit of Python code. So let's take a look at what we got here. Class is a new reserved word, kind of like def. We have the name of the class. That is a name that we choose. That's the name by which we'll refer to this class for the rest of this program. And it has a colon at the end of it, and which means it starts an indented block, which ends when we de-indent. Inside the class, there are generally two things. There is some data, and this just looks like an assignment statement in the class, x equals 0. And then there is a def. This looks just like a function, and then it starts with a def, has a colon, indents. So that function finishes right there. The difference is this is a method because it lives inside of a class. And so there is no function called party. There's a function called party within party animal class. And we'll talk in a second about this self thing. It is the way that inside this code we refer back to that variable. So this is not actually executing any code. It's sort of remembering the template, defining the class party animal. This is what we call constructing. We're constructing, using the party animal template or class, we are making a party animal. And then once we make that, we stick it in the variable an. And then we're going to call this party animal, this party method 3 times, 1, 2, 3. Now this self thing, and we'll take a look at the self. The self ends up being an alias of an. And so you can look at this syntax. It's just kind of an equivalent of this syntax. It's calling the party method within the party animal class and passing the instance in as the first parameter. And so self ends up being an alias of an each time these are called. Now if we make a different variable and a second object, which we will eventually, you will see that works a little bit differently. And so this syntax is a short version of that syntax. So if we watch how this executes, it starts up here, it just defines it, and then we construct it. And that's what basically constructing it, we know how to construct it because we look at the class and we make a variable x, we make some code party, and then we construct that. That's what the party animal does, and then we assign that into an. And so an is now pointing at that. Then when we call the party method, that basically takes this an and passes it in as the first parameter, which is used as self. And so self.x, which is what we're doing in this line right here, self.x is a variable. X starts out as 0. X starts out as 0 because when it was constructed it was set to 0. So we're in here, an is an alias of self, and now it looks up self.x, which is 0, adds 1 to it, and so this becomes 1. And then we print so far 1. And then the code returns and it goes down and does it again. And x becomes 2, prints out so far 2, comes back down, and does the last time, calls it again, self.x is 2, add 1 to it and stick it back in, so this becomes 3, and we print out 3. and then the program finishes. And so you can think of this as constructing the object and then associating it with this AN variable. Now that we've created this object, we can play around with things we've played around before with dir and type. We use dir and type to kind of inspect variables and types and objects. So we've been using objects all along. This code here says, hey, make me an empty list. Well, it turns out that what we're saying is there is already a list class inside of Python, and we're constructing an empty list, and when we get back this empty list, we're assigning that into X. So X, in a sense, contains or points to an empty list. So then we say, hey, what is in X? What kind of thing is X? Well, it's a list. This is a thing, it's a list type. Lists have list of things in them. And, use append and all the things we've been doing before, they're just objects. And then the dir, if you remember the dir is the capabilities. And there's all these internal capabilities that do things like implement the bracket operator, etc. Those double underscore ones, we can ignore them, although you can even look them up and figure out what they mean if you feel like it. But the methods that we tend to call are in this class. And so things like x.sort, I've always told you that is the sort method within the X thing, and the dot operator is the operator that we use to look something up within an object. And so you've been using this syntax all along. X.sort, dictionary.items, all of those are methods within the corresponding class. If we take a look at this line of code that we've been doing for a very long time, which says, oh, stick hello there into Y. If I reword that as more OO or object-oriented, what this single quote does says, make me a string object and put some text in it, and then when that is done being constructed, stick that into Y, right? And so Y now points to a string object that's been pre-initialized to the string hello there. Now that's a long way of saying hello there ends up in Y, but in OO terms we can talk about that. If we do a dir of that, we see a whole bunch of internal methods which have double underscores, and then we see all kinds of methods that we've been using. We've been using methods like Now I'm going to talk a little bit about object lifecycle. And what we mean by object lifecycle is the act of creating and destroying these objects. And I've been using this term constructor already. And so when we declare a variable, whether it's a string or a dictionary or a party animal, there we create them and then they're discarded, and there's all this dynamic memory that comes and goes. And we, as the writers of objects, have the ability to insert ourselves at the moment of object creation and at the moment of object destruction. And we make special functions that we call the constructor, the object constructor, or the class constructor, and the destructor. And we don't actually explicitly call them, they're called automatically by Python on our behalf. And so the constructor is much more commonly used. It's used to set up any initial values of variables if necessary, et cetera, et cetera. Destructors are, we'll cover them, but they're used very rarely. So here's a bit of code that we've got. It's our party animal, and a lot of it is the same as what we've been doing so far. So we have this variable x, and the constructor has a special name, underscore, underscore, init, underscore. Again, we pass in the instance of the object, self. And in this one, all we're going to do is print out that you're constructed. And here's this code that we've had before. And now we have underscore, underscore, del, and then we pass in self. And we'll just print out that we're being destructed and what the current value of x is for that particular instance. So let's go ahead and run this. And so again, this doesn't really do any code up to here. That just defines party animal, but this is the constructing of it. And basically that says, oh, and it really kind of creates these variables, and then it also runs the constructor. And so in this case, this line right here is causing the I am constructed message to come out. Then we do and party, and that says, 1 and 2. And here's an interesting thing. We're actually going to destroy this variable by throwing away an no longer points at that object. An is going to point to 42. So we're going to sort of overwrite an and put 42 in it. And at that point, Python's like, oh, this whole little object that I just created, somewhere it's out here, it's vaporizing it and throwing it away. And so before this line completes, it actually calls our destructor on our behalf. And so that message comes out. So we are allowed, as the builder of these objects, to add these little chunks of code that says, I want to be involved at the moment this object is created, and I want to be involved at the moment that this object is destroyed. Now, in this last line, an is no longer a party animal. An is now an integer. It's got a 42 in it. It's gone. It's been created, it was used, and then it was destroyed. Okay? So you got to be careful. If you overwrite something, you can sort of throw the object away. So the constructor is a special block of code that's called when the object is created to set the object up. So we can create lots of instances. Everything we've done so far is we make a class and then we create one instance, one object. And each of these objects ends up being stored in its own variable. We have a variable an and we've been using it. But the more interesting thing begins to happen when we have multiple instances of the same class sitting in different variables. And it has its own copy of the instance variables. So let's take a look at this. So this code here, I've taken out the destructor, and it shows a little bit more information. So now we're going to put two variables in here. We're going to have a current score or whatever, and a name. And we're going to start it out as blank. And this time we're going to add a parameter onto the constructor. And so the self comes in sort of automatically as the object is being constructed. But if we put a parameter on the constructor call, which is this party animal call, then this comes in as the z variable. And so self is the object itself, and z, this first parameter, is whatever parameter we put here. Everything we've done so far has no parameter here, but now we have a parameter here. And then that means that when we call this constructor, this line of code comes, and then name is no longer blank. Name is going to be Sally in this particular thing. And then I'll say, oh, self.name, which will be Sally, has been constructed. And so then we have this, and that object is now constructed, and then we put it in the variable s. And then we call the party method on that, and we construct a different one. And so this time it calls, and z is Jim, and we basically have a, another copy of this. And so this is how it's going to look, right? As it runs down here, when this is called, it makes one instance and stores that in the variable s. And there's a variable x in there, there's a name in there, there's an init method and party, and that's all in here, right? All that stuff is in here. And now we say, let's make, and that's going to have a Sally in there. All right, Sally in there. And then we're going to do another constructor, and so it's going to make a whole new thing, and it's going to store that in J, and this one's going to have Jim in it. S party, then this turns into a 1, and then we're going to call J party. That turns that into a 1, and then S party will cause this to be a 2. Okay, and so what happens is we have now two objects, one in the variable s and one in the variable j, and they have separate copies of their instance variables. These are the instance variables or the object fields or whatever, but they're the variables. But the key is that every time we do a new construction, it duplicates this, and there's another copy of it. So there's an x within s. So s dot x is this variable, and j dot x is that variable. Okay? So the next thing we'll talk about is inheritance, and that's the idea of taking one class and extending it to make something new. So the last topic we'll talk about here in object orientation is the notion of inheritance. And this is a form of code reuse, and it's one of the more advanced aspects of object-oriented programming. So just kind of understand what it is at a high level, and then you know where to come back to when you need to learn a bit more about inheritance. So the idea is, instead of making a new class from scratch, we actually make a new class by starting with an existing class. We are extending it, or another word for this is subclassing. And it's sort of a situation where you're like, I've got this code and I've got this data, and I just need to add a few things to it, and then I'll have a whole new thing. And as you design objects and what we call object hierarchies, you often do this, and it's a form of sort of real clever code reuse. But again, don't necessarily think that you're supposed to know when to use this or why to use this. Right now, it's just terminology, okay? Just terminology. We have what call these as parent-child relationships. The original class is called a parent, and the new class is called the child class. So subclasses are another word for this. You have a class and then you subclass it. I think extending, inheriting, and parent-child are probably better ways of expressing it than subclassing. So here's a bit of code. Let's take a look at this. This code's unchanged. It's the party animal code that we've been saying all along. It's the one that we construct and put a name in. And now what we're going to do is extend it. And so you'll notice that this code down here is the part that's doing the extending. So we're making a new class, football fan, and by putting in parentheses before the colon, party animal, that says football fan inherits everything that is party animal, meaning the X, the name, the init, the party, all those methods and data are sitting there, and now we're going to add a new variable. So football fan has, in addition to all those other variables, it has points, and it has a touchdown method. And self points is added, we add 7 to the points, and then we call the party, and that does that. So this is calling this method because football fan includes X, name, and party, and init, and everything, and all this stuff, this constructor. So this football fan is really an amalgamation of all these things together. Party animal is just this stuff, right? And so we still have two classes. We don't just have one. We didn't erase the party animal class. And so if we take a look at the code that we can run here, we can say, oh, okay, let's make a party animal, Sally, and so that constructs an object like this and then stores that in S, and with an X starting out at 0, and then we call S party. Oops, better change that color. Starts out at 0, and then we call the party method, and that changes it to 1. Okay, and so this bit of code, it's as if this part doesn't matter at all because it is a party animal, it's not a football fan. But now if we take a look at this code down here, take this code down here, we're going to construct a football fan and pass in Jim. But football fan has no underscore init, so that actually uses the underscore init from party animal because we extended party animal to make football fan. So we inherited all of the good that was in there. So there it's going to make a name, a variable X, which is going to start at 0, a variable name that's going to have Jim in it, and a variable points that's going to have a 0 in it. So this J variable has more things in it than the S variable has. And so we can call the J party, and if we call J party, that goes here and adds 1 to X, right? So that adds 1 to X, and then we call J touchdown. Well, that comes down in here and adds 7 to the points, right? And then calls party within us. And so self.party is the current object, i.e. self and J are the same thing, right? Self.party, and then it goes up here and passes self in, and it adds 1 to the X, in this case of this J variable. So this becomes 2. And that's where it prints out. It prints out, 7 and 2, and away you go. And so it's a way for you to kind of take all this stuff and stuff it into a class by making a new class and just add the extending bits, the bits that are in addition to the other stuff. So like I said, inheritance is a powerful and wonderful concept. It's a form of, excellent form of reuse. But basically, the whole purpose of this lecture was so that I could in the future just use these words and you would understand them, as compared to, I just want to say method. And I've been saying method all along, and it's high time that I defined it. So let's just review one last time. Class is a template. It is not actually a thing. It is a shape of a thing. And we define it and say, when we make one of these things, it's going to have these variables in it. It's going to have these methods in it. Attributes, variables within a class. Method is a function that's inside of a class. Object is once we construct a class, we get back an object. And so object here is the snowman cookies. Class is the snowman cookie cutter. And a constructor is a bit of code that sets up our object, our instance, when it first is created. And inheritance is this ability to create a new class, but take all and import and affect all the capabilities of an existing class. So, object-oriented is awesome. For the rest of this class, we're not going to write any object code. We're not going to use class at all, but we are going to use objects. And literally, you've been using objects from the beginning of this course. As soon as you said print, whoops, as soon as you said, x equals high, that's an object. And as soon as you said x.upper, you were calling a method, right? You've been calling a method all along. When you're doing something like fh equals open, this thing you're getting back, that's an object. And then you do fh.read or whatever. You're calling a method in the dot operator. So you've been using objects all along. I now am just finally explaining to you when I say call the read method or call the upper method or what's this little dot and why is that there? So again, it's time for us to understand that, but it will take you a long time before you encounter a problem that's large enough where as part of your solution, you're going to make a new object. But when you do, it's really a powerful thing. I mean, it's a really bad idea for me as a teacher to say, oh, write a bunch of objects. It's like, it's premature for that. It's later is when you will actually learn how to use objects and you'll be like, oh, thank heaven that these objects are here. Okay? So, that's all for now. Thanks for listening. See you on the net.